Hi everybody, it's Miss Moran. We're going to work here on Unit 6, Video 3. We are writing polynomials given zeros. This time we're going to have different zeros. So I know you already watched Video 2 on this concept, so it's going to follow very closely to what we did there, except we're going to have some multiplicity occurring and we're going to have some irrational and complex zeros. Let's get started. All right, our first example is given zeros with multiplicity involved. So we're going to write a polynomial of least degree with real coefficients that has the zeros of 4 and 2. Now our zero of 4 has a multiplicity, which means it's a repeated zero. And we also have to make sure that we satisfy that f of 1 equals negative 18. So let's take a look at what least degree means. Least degree is going to tell us that the only multiplicity that exists is the multiplicity they tell us. And if they don't tell us about any multiplicity, we can assume that every zero is unique and it is not repeated. And so if they give us 5 zeros, then it is a degree of 5. Well, here they actually only give us 2 zeros, but one has a multiplicity of 2, which means we actually have a least degree of 3, a cubic, when we finish. So let's get started and say, well, I actually have I have x equals 4 twice and x equals 2. So that's going to give me x minus 4, and x minus 2. Now they're telling us this extra information, which means that we're going to have a lead coefficient other than 1. So I'm going to put in a for that lead coefficient, and we're going to use the f of 1 equals negative 18 to find it. We're going to do that first. So negative 18 equals a times 1 minus 4 times 1 minus 4 times 1 minus 2, or negative 18 equals a times negative 3 times negative 3 times negative 1, or, continuing, we get negative 9a, and a equals 2. So if we return to this spot right up here, and we substitute in that 2, I will have this. And I'm actually going to write it a little differently for you. We're going to write it with squared because that shows another way of showing our multiplicity, that particular factor and that 0 is repeated. So I do have to continue and expand this. We're going to expand x minus 4 squared first. So I will have 2 times x squared minus 8x plus 16 times x minus 2. Next, I will multiply out my trinomial times my binomial. I'm going to use that rectangle. It's a great way for me to stay organized. X squared minus 8x and a 16. And that gives me x cubed minus 8x squared and 16x, negative 2x squared, positive 16x, and negative 32. And I'm going to sum that up over here and simplify it. X cubed minus 10x squared plus 32x minus 32. And I can't forget that we did have a lead coefficient of 2, so I'm going to distribute that all the way through. And that will leave me with my final answer of f of x equals 2x cubed minus 20x squared plus 64x minus 64. And that is a polynomial that satisfies all of my givens. It is of least degree, real coefficients. I have the zeros of 4 and 2, and my 4 is a repeated root, and also satisfies f of 1 equals negative 18. Let's try another example. My second example is given irrational zeros. Well, irrational zeros means that there were square roots involved, most often when there are square roots involved. So I have 2 plus the square root of 3. Well, in order to have gotten the square root of 3, I had to take the square root when solving. When I take the square root and I'm solving, I always have plus or minus that radical. So even though it says that I have zeros of 1 and 2 plus root 3, I actually have another one of 2 minus the square root of 3. So that's how I'm going to begin this problem. I will have the factors of x minus 1 because of my 1, and then I will have the factors of x minus 2 plus the square root of 3, and x minus 2 minus the square root of 3. I'm going to clean up these this double set of parentheses by distributing the negatives. So x minus 1, x minus 2 minus the square root of 3, and x minus 2 plus the square root of 3. Let me caution you that because these problems have a lot of multiplying polynomials out, you do need to stay organized. So whatever you do, make sure you're either staying linearly, like you're just stacking each step on top of each other, or you're just kind of making your steps very clear to read. First, for you to look back at your mistakes, but also in case there's someone assessing your work and reviewing your work, we can help you find out where those mistakes might be. So I'm going to multiply these two first, and I'm going to use one of those large Punnett squares to do it to keep me organized. And here we go. We get x squared minus 2x, and then minus x root 3. Over here we'll get negative 2x, positive 4, and 2 root 3. Here x root 3, negative 2 root 3, and minus 3, because the square root of 3 times the square root of 3 is the square root of 9, so we're going to get a minus 3 there. You should notice that there are things that are opposites inside of our table here, and that shouldn't surprise you because these two are conjugates. They're opposites of each other here. And let's go ahead and simplify that out. I will grab yet another color here to make it easier. I've got these two are opposites, those two are opposites, and we'll combine like terms. So I get x squared minus 4x plus 1. I need to still multiply out that x minus 1 onto this trinomial. So I will yet again use, I love this Punnett square idea. Not so much a square this time, but x minus 1 to give me x cubed minus 4x squared and an x, negative x squared 4x minus 1. So I am at my final step here where I will combine all my like terms to get x cubed minus 5x squared plus 5x minus 1. This polynomial is of least degree. It had to have a power of 3 because I had the two distinct zeros written, and this one had to have a conjugate because of the radical, the square root of 3. So I had to have a cubic power. I have all real coefficients, and that's my final answer. Let's try one more example together. All right, this time I'm going to be given some complex zeros, so I've got some imaginary numbers. Once again, I want a polynomial of least degree having only real coefficients and the following zeros: negative 1, 2, and 3 plus 2i. Okay, similar to the last one, if I have a imaginary number, imaginary numbers came from reducing radicals. Well, if I had radicals, then I had to have to take the square root when solving, which means I should have had plus or minus. So if they tell me that one of my zeros is 3 plus 2i, that means that there's also a zero of 3 minus 2i. They don't have to tell me both because it is assumed if I had one, the other is also there. Looking at all of this, that means I'm going to have a polynomial of degree 4. I've got 3 plus 2i, 3 minus 2i, and then the two real zeros. So this has a degree of 4. Let's start by finding the factors: x plus 1, x minus 2, x minus 3 plus 2i, and x minus 3 minus 2i. I'm going to multiply my real ones together, I'm going to multiply my imaginary ones together, and I will then multiply those final polynomials together. So here's my two reals being multiplied: x squared minus x minus 2. These two I'm going to use that giant Punnett cube for, Punnett square. So I'm going to change colors so we can see that clearly. I should have x minus 3, 2i, x minus 3, negative 2I x squared minus 3x, 2ix, here negative 3x, positive 9, and negative 6I, negative 2ix, 6I, and negative 4I squared. Okay, once again, we see some opposites, so we're going to get rid of those opposites. We can cancel out my negative 2ix, we can cancel out my 6i's, and I'm going to change this to plus 4 because my I squared represents a negative 1. So this becomes x squared minus 6x plus 13. So I need to multiply x squared minus x minus 2 times x squared minus 6x plus 13. This is why saying organized is very important. You don't want to lose one part but while you go work on the other part. So we'll make one more large square, x squared minus 6x and a 13, x squared, negative x and a negative 2. Change color so you can see what I'm writing inside. X to the 4th minus 6x cubed and 13x squared. Negative x cubed, 6x squared, and negative 13x. Negative 2x squared, 12x, and negative 26. Clean it all up and we have our polynomial. F of x equals x to the 4th minus 7x cubed. I've got, let's see, negative 2, positive 6, and a positive 13 gives me 17 x squared minus x minus 26. This is a polynomial of least degree having only real coefficients with zeros of negative 1, 2, and then my complex zeros of 3 plus 2i and 3 minus 2i. All right, the assignment we've got for you is on page 330, numbers 53, 57, 63, and 71. There are 4 examples. You can check your answers in the back of the book to make sure that you've got it right. You also need to log on to Schoology and take the quiz that is titled Unit 6 Video 3 Entrance Slip. It's going to be found in the materials section of the class in the Unit 6 folder. Completion and accuracy of this quiz will be a part of your homework score. Make sure that you're careful on your answers. After this lesson, you should be able to write and expand an equation of a polynomial with given zeros and another point. In this one, different than video 2, we had complex zeros and we also worked with some irrational zeros.